Hi, my name is John Burks, and I'm doing a series of mini videos regarding several software applications that anybody can use in their organizations to improve their business processes. The first application or video that I shown was Alteryx. Second video was the output to Excel, and this is the third video in a series of several videos that I will be creating. Now, in the last video, we showed that some of the outputs that you generate from Alteryx do not populate the Excel workbook correctly. And that's why you use the reporting tool, which is one of the reports that I generated from. This is one of the reports that I generated with the reporting tool. Now, this is the Pearson correlation analysis. Now, this test can be run if your data is normal. If your data is not normal, you can use the Spearman correlation. And both of these type of statistical methods are available in the data investigation tool in the Alteryx application or software. And what I did was I looked at the units sold and I wanted to see if there was a relationship between the sale price. And as you can see, you have a weak correlation, but of 0.068, and it's also negatively correlated. Now, keep in mind, correlation and causation are two separate things. Correlation has to do with relationship, and it does not determine if there's a causation between your two variables. Okay. Now, I also looked at the p-values, and what we have in front of us, we're looking at the units sold again, and the sale price, and what the p-value is letting you know if the coefficients are statistically significant. And if you use a level of significance of 0.05, as you can see, our p-value is greater than 0.05, so we would fail to reject the null hypothesis. So this means that our coefficients or our slopes of the two variables are not statistically significant, and what I would do is go in and try to look for two variables that are more related. And on this tab, what we have is the distribution of analysis. And what this shows us is your shape of your data, your spread of your data, as well as your central tendency. This lets you know whether or not your data is normal or not, so that way you can choose the right statistical test. And so we have skew, which is 0.44, which is shape of your data. You have the number or the count, which is 700. You have the mean, which is related to central tendency of 1608, the medium of 1542, which is also central tendency, and then you have standard deviation, which shows your spread. And as you can see, as you scroll down as well, Alteryx allows you to do different types of tests, the normal, the log normal, and the Weibull, and it gives you your level of significance. And it also gives you some information regarding the chi-square significance against the this chi-square significance, and also gives you some information regarding values greater than 0.05. Now, we have a frequency table. Typically, when you're doing statistical analysis, if you have continuous or discrete data, you can use descriptive statistics, and you can view that data in histograms as well as box plots. But when you have categorical or nominal data, you would have to use either a frequency table, and you can look at that data in different types of charts. And what I did was I took the segment and I looked at the product type, and I generated this frequency table. So the rows are the column is my product type, and the rows are my segments. And as you can see, the frequency gives you the count. So for this channel and for this segment and then this product, it gives you the frequency all the way across. Okay. And then it gives you the total. And then it gives you the percent. Okay. And as you go down, at the very bottom, it gives you the frequency of all of your products. Okay. And then it gives you the percent of this product. And at the very end, you see it totals 100. And then if you notice, this 700 equals the 700 over here, which is the count, or your n. And at the very bottom, it gives you a chi-squared value, your degrees of freedom, and then your p-value of 0.9277 if you wanted to do some more hypothesis or statistical analysis. And lastly, I have a regression report. And what I want to do is model using one of the variables from the report. So I looked at the segment to see if I can predict revenues based on the segment. And what this report does, it shows you the min, the first quartile, the median, the third quartile, and then the max of the revenues. And then when I look at the actual values, what you want to do is look at your significant codes, and if it has 3 stars, it's letting you know that these coefficients are statistically significant. And as you can see, the enterprise, the government, and then the segment small business are statistically significant. And then you have the mid-market, which is not. So what you can do is remove the mid-market, retest your model to see if all your values are statistically significant. The thing is, if you are leaving values that are not, your model will not predict the revenues as well as you want. And then what you also want to do is look at the adjusted R-squared. And what this is telling me is that only 54% of the variability is explained in this model. So you want to see that a little bit higher. So maybe if you remove the mid-market, rerun it, you might get a higher adjusted square between somewhere around 80 and 90 or above. And also what I have is the p-value associated with the f. I have the sum of the squares, the degrees of freedom, and then the f value. And what this is showing me is the residuals, which would be the difference between the actual amount versus the predicted amount or predicted line. And then you square those values, and then you sum up all those squares, you sum up all those squared values, and you find the least one, or it's called the sum of the least squares. So that way you're able to get the best fit in line or for your model. Again, this is the degrees of freedom. And then we have our f value. What that is looking at is the sum of the squares of the sum of the square difference between the variables and over the sum of the squares within the variables, which is another computation or formula a formula that is used to find the f value. And then you look at the f value, compare that to the f critical values to see if you also should reject the your hypothesis. Okay, and then down here you have some other graphs showing the residuals versus the fitted. Okay, now this was the reporting video. I really done at a really fast pace. I do have another video that goes at a much slower pace that I think anybody can grasp, and it will definitely benefit you if you are in the field of statistics, or you're an analyst, or you just want to learn more about statistics. Okay, so having said that, the next video will be Tableau. And if you want to see a longer version of these videos, I do have it all on my LinkedIn profile. Thank you, and I'll talk to you shortly.